Alright, welcome everyone. This is our first video from a different house. Notice the screen is different because I'm on a black desk instead. So great. Anyways, let's get going on this review packet here. So these first two problems are all about the cross sections, which means that you are taking a plane or a piece of paper and chopping through this figure and trying to figure out what shape is created. So for instance, on letter A, this is a horizontal plane that passes through point T. So here's an example, just drawing it all the way in. Passing through point T, and you'll end up getting a rectangle here actually. If you said parallelogram, that's okay, because rectangle is a type of parallelogram, so I give you full credit. Continuing on, this letter B, a vertical plane that passes through point T and is perpendicular to the trapezoidal bases. So in other words, it's perpendicular to these two bases. So what that means is it goes straight up and down, and it passes through in a perpendicular way to those guys. So it goes kind of straight down here and creates this shape here, and then yet again, it is yet another rectangle. And a vertical plane that passes through points A and point R. So it kind of goes like this, goes down like this through the figure, and again yet another rectangle. Rectangles all over the place on this guy. Really not too big a deal. Yeah. So a vertical plane that passes through points A and B, we again cross through all these points here, and if we do it, it creates again a rectangle. Rectangles all over the place. Not every single one of these is going to be a rectangle, but it definitely does lots of rectangles. A horizontal plane that passes through C and D. Oh my gosh, it's just rectangles everywhere. All these are rectangles. I hope they're not all rectangles. A vertical plane that passes through point E and is parallel to the bases of the cylinder. So finally we have one that's not. So it actually ends up going around the cylinder because you're cutting it through this axis, slicing right through the middle. It creates a perfect circle. We're going to go ahead and cross off letter D because this is covers something we didn't do. The answer is actually a parabola, if you really care. It creates this really weird looking shape, looking like this, kind of like a U, but we're not going to deal with that one. It says here that you have to sketch it. This is what I was hoping for a sketch, but if you want to draw the picture over here, that's cool too. Anyways, so number 3. Paint roller has the shape of a cylinder. The roller is 12 inches long and a diameter of 3 inches. So that means that this guy right here is 1.5. The radius has got to be a 1.5. And it says if you rolled the paint roller that is completely covered in one full rotation on the wall, what shape will it make? I mean, you could imagine rolling paint over a wall here. It's going to create a rectangle. The rectangle is going to create, this side's going to be 12 because it's the length of the roller itself. And then you're rolling it all the way out. What is this length going to be? I'll give you the answer first. It's going to be 2 times pi times the radius, which is 1.5. And actually, this is the answer down here. 12 by 3 pi, what that ends up being. Why is this the case? Well, if you imagine, I'm actually just going to roll this paper up. If I were to roll the paper up in a circle like this, you can see the top here creates a circle. If I can actually make it, it's too hard. I give up. It's a circle if you were to roll that paper up at the top. And circles have a circumference. The circumference of a circle is 2 times pi times the radius. And the radius of that circle is 2 pi r. And if you unroll it, well, my paper is obviously a rectangle. And that length there is the circumference of the circle. What area would it make? We just got to multiply these two guys. It says round to the nearest tenth. So 12 times 3 times pi, and the nearest tenth, this is 113.1, and inches, do not forget your units, inches squared for area. On to the second page. So in this question, very similar to that front page, you're trying to do a 3-dimensional something, but now we have the cross section, if you will, and we're twirling it around the axis. So we're twirling it around AB. So we're twirling this way through the paper and coming out. It actually, on the other side, it creates a circle. On the other side, it creates a cylinder, and it's coming through because you're twirling around, so it creates that cylinder. What does it say you have to do? Draw the sketch and then find the volume of the solid. So the volume of this one, the volume of the sphere, is going to be 4 over 3 times pi times the radius cubed, in this case 5 cubed. And the volume of the cylinder, again, please don't forget we have a formula sheet for this test. You may use that formula sheet as you need. It's going to be pi multiplied by the radius squared multiplied by the height. So the overall solid is the volume of the whole thing. If you just add all these numbers together. So we just got to add everything up. So that's going to be 4/3. I'm going to type it in as 4 divided by 3 in the calculator like so, or I just did parentheses around it. Oh, it's really hard to see. What if I put it there? Any bet? Oh, it's like worse. Over here. Ooh, you could see it there. I'm gonna leave the calculator right there. All right, so we got 4 divided by 3 multiplied by pi multiplied by 5 to the 3rd power, and then we have to add that to pi times 5 squared times 8. And if you didn't see how I did that 5 to the 3rd power, by the way, this guy, I'm just going to delete this one so you can see it one more time so you can actually see me type that in. What I did is I hit the caret key and then the number 3, and that will give me my answer. So it looks like the overall volume is 1,151.9, and it doesn't really give me units, so I'm just going to say units cubed because volume is cubic. So this guy, if we were rotating it around the CD, you're going to twirl it this way. Twirling it this way, you're going to create a cylinder, and overall the two ends end up making a sphere. So you end up with a sphere of radius 5, so it's actually exactly the same as the previous question. And the volume of the cylinder, well, that's going to be pi multiplied by the radius squared, which is 5 squared, times the height, and the height of this one is 9. Just got to add all of these together. So I have to use this again, so I'm just going to use that. The only thing I have to change is this to 9. It's almost the same answer. 1230.5, and then again units cubed. Cool stuff. Draw a two-dimensional sketch of the cross-section of the given plane in the figure below. So the figure and a vertical plane passing through point A. So a vertical plane passing through point A. So it's going to create this shape, and then it's going to go straight down. It's like an ice cream cone. So you don't actually have to find any volumes. You just draw the picture. Kind of looks like that. Easy enough. The figure in a horizontal plane passing through point C. So your piece of paper goes through the center here, ends up creating a nice perfect little circle. Don't forget, if you're really struggling with these, I highly recommend going to this website. I wonder if I can actually just use my computer to switch over to seeing what's on my screen. I'm going to open up that website and see if that'll work. Let's see. Just give me a second, guys. Let's see, sources. I'm going to add a source. I'm figuring out how to use this program as we speak. This is a fun little adventure. How's it going, guys? I don't have a shout out for us today, so instead, shout out to my girlfriend. She is currently grading your geometry tests. So thank you. I appreciate it. Window capture, that's what I want to do. Hit the window capture. Which capture do I want to do? There's girlfriend hand. All right, she got you guys. Crushed. Oh man, that is funny. And there it is. I have figured it out, I believe. So just give me a second. So this is on Google Classroom. So you know what? I'll just go to Google Classroom and click through it so you guys can kind of see if you want to mess around with this yourself. It's really not a bad thing to do. Let me get to my Google Classroom here. So, all right. Clicking buttons. I'm on Google Classroom now. All right, now I can finally share the screen. Capture multi-adapter compatibility. I don't even know what all these things mean, but all right. Let's see. It's there. We're on screen capture. So here we go. And you can see the bottom, man. This is like unprofessional. Let me tell you. All right, screened out. Now we're good. Now we're going back to this. I hope you guys can see what's going to end up happening. But on Google Classroom, I have posted this, the cross sections. Just click it. And let's check this out. So we are working with a cone and a sphere on top of it. So let's just click the cone one so you guys can see like at least the circle that I was talking about just now. So the previous question has this circle, and if you notice, the slice that goes right through the middle ends up creating this perfect little circle. And you can mess with this program and kind of rotate things around, and it will create all kinds of funky shapes. That's called a parabola. We're not even doing those. Yeah, these are weird. And the slice can go up and down. That's called an ellipse or an oval. It goes up to a point. If you really want to do this, you can get all kinds of funky looking shapes. You can mess with a cylinder too. Whee! It's all kinds of cool stuff. You know, just have fun with it. There's our rectangle that I was talking about. You cut it one way, you get a circle. If you cut it another way, you get a parabola. If you cut it through one side like this. Very strange stuff. Anyways, I gotta exit out of this now. Let's like turn this off. How do I do I just hit the lock button? No, that's not it. Oh, the minus button. Oh, that turned the wrong one off. That turned my document camera off. Window capture off. Yeah, I don't know. Hopefully everything's still cool. All right, let's get back to work on this thing. Number 7. I did number 8 too. I didn't even do it in order. The figure in a horizontal plane passing through point B. So in a horizontal plane. So actually this also creates a circle going through this sphere. So it creates a perfect circle again. And a figure passing through a vertical plane and point B. So this creates a very strange looking shape. It kind of comes down like this to create a half circle on top. And then it creates that like a straight line going down, and it ends up coming to a single point. Actually creates another one of these guys, which is kind of weird looking, but we're just not going to deal with it. I'm not really interested in this problem. We can just kind of skip number 9. Let's do number 10 instead. This is such an important question, and I need to like move my mouse so it can... No! No, I spilled Dr. Pepper, guys. Everything's a disaster. Everything's a disaster. 1 second, team. 1 second, fam. Oh, man. No, we're going to keep recording, definitely. It's okay. We're going to clean this up. We're going to keep on moving on. Everything is all right. We are going to clean this up nice and fast. And I'm gonna be a professional YouTuber. You know, this is my job. I just spill stuff and kind of do it, and hopefully things don't go too bad. I'll clean this up nicer later. I should clean it up nicer right now. What a disaster, guys. Alright, we're moving the mouse pad. Here's the mouse pad in question that is causing all of these problems. And it's on the floor now. I gave up. Finally, we can actually do problem number 10. Yay. Alright, so show and describe what happens to the volume for the following solid if all the dimensions are multiplied by 1/3. So we're going to do this problem 2 different ways. We're going to take the long route, and then I'm going to show you the short route that you would rather do that's a lot better. So the original volume of this shape, we have a cylinder and we have a cone on the bottom. So the volume of a cylinder is going to be pi multiplied by the radius squared times the height. And the volume of the cone, that's going to be equal to 1/3 times pi times the radius, which is 9 squared, and then multiplied by the height, which is 12. So the original volume of this situation is all these things added together. So we're going to go ahead and do pi multiplied by 9 squared times 6, and add that to 1 divided by 3 times pi times 9 squared times 12. Hit enter, and we get this original volume of 2544.7 and centimeters cubed. Now, what is it changed by factor? Well, I'm going to figure out this last, and I'm going to show you the way that you can figure it out the first way. So the new volume is instead the new volume, NV I'm going to call it, of the cylinder. every single thing has been multiplied by a third or divided by 3. So that's going to be a 2 centimeters here, a 3 centimeters there, and a 4 centimeters there. So our new volume of the cylinder is pi multiplied by 3 squared times 2, and the new volume of the cone is going to be 1/3 times pi times, what is this going to be, 3 squared times 4. So just going back in and going into this thing. Oh yeah, don't forget I have to leave it there, otherwise it's like not visible. Just scroll up here and change this to a 3, change this to a 2, change that to a 3, and change this to a 4, and our new volume is now 94.2 centimeters cubed. So what actually happened here? How did I get from one to another? Well, if I go from here to here and divide this guy divided by this guy, that is to say I take this guy and divide by this guy, I get this number, 0.037, 0.037, 0.037, and you can hit math, enter, enter to convert this. It didn't convert it for me. Well, the conversion factor is 0.037, but I don't like that number. That is to say I have to multiply this guy by 0.037 to 94.2. But you could have done this problem a lot faster. You didn't actually have to find this entire new volume. You could have remembered the rule. If all of the sides are multiplied by 1/3, all the dimensions are multiplied by 1/3, that means the volume must be multiplied by 1/3 times 1/3 times 1/3, or 1/3 cubed. That's the actual change factor, 1/3 cubed. 1/3 cubed is 1/27. And if you do the little math on it, 1 divided by 27, sure enough, is this 0.0307, 0.0307, which is what we were looking for in the first place. So if I just take that original value and multiply by 1 divided by 27, I will get that answer of 94.2. Easy enough. Let's go to the next page. Let's do this number 11 in that fashion, where we find the original volume, we multiply it by the correct scale factor, and then find the new one. So the volume of this sphere, the original sphere, is going to be equal to 4/3 multiplied by pi multiplied by 15 cubed. 15 because the radius here is 15. So the original volume here is 4 divided by 3 multiplied by pi multiplied by 15. Again, to do the cubic, you raise it to power, do the power 3, and you get this 14,137.2. And what is that? Unit's going to be yards. Yards cubed. That is a massive thing, by the way. That's pretty big. Pretty big beach ball there. And it's changed by a factor. If all the sides are multiplied by 4, the change by factor for the volume is 4 cubed, which is 64. So I'm just going to take that number, multiply by 64, and get the new volume of 904,778.7. You could also get 0.6. I would have accepted that answer because this is barely different. And again, yards cubed. Surface area. The surface area of a sphere, or area of a sphere, some people call it, is 4 times pi multiplied by the radius squared. The radius squared is 15. So we got 4 times pi times 15 squared. And that's going to be 2,827.4 yards squared. The change by factor here, because it is area, it doesn't go cubic, it goes squared. So we're going to multiply instead by 4 squared, which is 16. So we multiply by 16, which is 45,238.9 yards squared. And if you had a slightly different answer because you ended up with a 0.2 or whatever because you didn't have that answer, everything is cool. All right, so number 12, I did this entire question in class. So I'm not going to go over this one on the video super in depth, but I'll at least remind you of the key points here, just so we can talk about it one more time. So if 1 cubic foot weighs 150 pounds and there's 5,000 pounds in this thing, how many cubic feet are there? Well, that's going to be 5,000 divided by 150, which is approximately 33.3 repeating, or actually exactly, not approximately. What's that going to be? Feet cubes. It says, what is the volume of the pile in cubic inches? Now this question, not going to actually show up on the test, but it is a good thought process, so I'll just bring it up one more time. We'll take this 33.3 repeating feet cubed, but instead of writing feet cubed, I'm going to write feet times feet times feet. And the reason why I'm going to do that is because in order to convert into inches, I don't actually only multiply by 12 inches in a foot. I multiply by another 12 inches in a foot and another 12 inches in a foot because it is a cubic thing, so I have to multiply it by the cube of 12. It's like a scale factor of 12, if you will. 12 times 12 times 12, 12 cubed. So all these feet are going to cancel, and I'm going to end up at, let's do this, 5,000 divided by 150, multiplied by 12 times 12 times 12, and we'll get 57,600 inches cubed. Part C, what is the radius and height of the gravel pile in inches? Well, the gravel pile, it says in the problem that the length of the radius and the height are the same. So I'm going to give the length of the radius an x and the height another x. And therefore the volume of the cone, which is 57,600, got to be equal to 1/3 multiplied by pi multiplied by the radius squared, which is x squared, times x again. So x squared times x is x cubed. So first things first, I multiply both sides by 3 to get this to be 172,800, and the 1/3 goes away now. Pi times x cubed. Rewriting this, I'm going to get 172,800 divided by pi, and that's what x cubed is. So if I take the cube root of that, I'll get what x is. And in the calculator, in order to do this, we're going to want to hit the math button first. Scroll down to number 4 for cube root. And then you want to type in this fraction, 172,800 divided by pi, and that's going to give us 38.03 inches cubed. Not too bad. Letter D, if the gravel was spread out so it covered as much ground as 2 inches thick, how much area on the ground would it cover? Well, in the end, we're going to have the volume of a box we know was, the volume of the box is 38.03, and that has to be equal to the area of the base, which is what we're looking for. We're looking for this area up there, multiplied by 2. So if you just divide both sides by 2, you just get the base is the area that it will cover, which is 19.01. Oh, this is not the volume. Oh my god, 38 is not the volume. I'm so sorry, guys. That is not the volume at all. Oh my gosh. The volume was given up here. This was the length of the radius. In other words, it's not inches cubed. It's inches to the 1 power. I'm sorry about that. So it's actually going to be 57,600 equals, again, base times 2. Divide both sides by 2. We end up with 28,800 inches squared. Again, nothing quite this difficult on the actual test. It's somewhat similar, but it's actually a lot easier than this. It's mainly like letter A and letter C are the questions that it's like, where it's just not as bad. Number 13. This is another question I did in class, but I'm just going to go over it one more time again. So we got the volume, because we're spinning this thing around the axis, so it's actually really similar to that previous question. By the way, on my Google Classroom, there is yet again another one of those things to look at where you can mess around and check out how to do these yourself. So what I'm doing is I'm creating the other end because I'm spinning this around this axis, around and around. Creates a cone over here and a cylinder over here. The volume of the cone is again 1/3 times pi times the radius squared. What's the radius here? Well, the radius of the cone is going to be 1, 2, 3 squared times the height. The height is 1, 2, 3, 4, 5. And the volume of the cylinder, well, that's going to be equal to pi times the radius squared. The radius is 1, 2, 3, 4 here, so 4 squared times the height, which is also 4 if you count it up. So the overall volume here, there are a couple ways to do it. If you add all these things up, you end up getting 79 pi. If you do all this extra math and do all that. Or if you just plug it into your calculator, you can do that too, which is 79 times pi, and you get 248.2 feet cubed, because it said things in feet. Let's do the last page here, guys. So on this last page, first of all, we're not doing any surface area questions, so you can just cross off number 16 completely, and you can cross off the surface area part of number 15. Some of this, and you can also cross off B because it's the same problem. So you're rotating this guy around the y-axis. If you rotate it around the y-axis, you get this shape going on, which is a sphere. That's a perfect circle, by the way. So the volume of our sphere is, again, 4 over 3 times pi times the radius cubed. The radius here is 1, 2, 3. And you could either leave this as 36 pi or I think it's like 113. It's the same answer as earlier in the page. Yeah, 113.1 inches cubed. And the area, the surface area of a sphere is 4 times pi times the radius. And if you don't remember these things, don't forget, you got that formula sheet. You actually get exactly the same answer, 36 pi or 113.1, but now it's inches squared. Last problem, the volume of the prism. Remember that the volume of any prism, we've been doing this quite a bit in class, is the area of the base multiplied by the height perpendicular to that base, or the base times the height. In your formula sheet, it shows up as B times H. It means the area of the base times the height. So the area of the base of this thing is going to be 1/2 multiplied by 3 times 5, because the base of this thing is this triangle that has a base of 5 and a height of 3. And the height of the entire solid is this 6 up here. You multiply all these things together, and you're going to end up with, let's see, 1/2 times 6 is 3, 3 times 3 times 5 is 45, and it's inches cubed. All right, well, I'm going to go ahead and clean up my computer more after that Dr. Pepper disaster, and good luck on this test on Friday, guys. Have a good one.